Let's continue our discussion of average rate of change. We found before that average rate of change between x equals x1 and x equals x2 is calculated the same as slope, which is delta y over delta x, or in other words, y2 minus y1 over x2 minus x1. We also pointed out that the units of rate of change, average rate of change, and slope are all the same, which is the units of y over the units of x. We were studying the example of the population of Holyoke from 2000 to 2008. We found that the average rate of change from 2000 to 2002 was 220.5. The average rate of change from 2002 to 2004 was 136. The average rate of change from 2004 to 2006 was 33.5. And the average rate of change from 2006 to 2008 was negative 179, which meant that we lost 179 people per year. Is the population increasing? The answer is that it is sometimes. So the next question is, when is the population increasing? Looking at the graph, we can see that the population is increasing from 2000 until 2006. Can we see this without the graph and just from the average rate of change? Yes, when the average rate of change is positive, that means we have positive change, the function is increasing. For linear functions, we said that y equals mx plus b is increasing if the slope m, or delta y over delta x, is greater than 0. And we said that a linear function was decreasing if the slope delta y over delta x is less than 0. We now want to define what it means for a function to be increasing or decreasing even if we don't have a line. Now we can say that a function y equals f of x is increasing if the average rate of change, delta y over delta x, is greater than 0. And the function is decreasing if the average rate of change, delta y over delta x, is negative. We can now compute whether a function is increasing or decreasing, even if it is not a line, by replacing the idea of slope with rate of change. Since the average rate of change is not always the same, like with slope, the average rate of change itself changes. If we look at our last example, we can see that the average rates of change are changing. Notice that the average rate of change decreases from 220.5 to negative 179. In this case, we say that the function is concave down. To define this formally, we say that a function is concave down if the average rate of change is decreasing. If we think about this in terms of the graph, the function can either be increasing but at a slower rate, as this graph is on the left-hand side, or decreasing at a faster and faster rate, as it is on the right-hand side. Similarly, we define that a function is concave up if the average rate of change is increasing. If we think about it in terms of the graph, the function can either be decreasing but at a slower rate, as this graph is on the left-hand side, or increasing at a faster and faster rate, as this graph is on the right-hand side.